Computationalist functionalism doesn't claim by itself that computers can think. That's not what it says. It doesn't say that von Neumann machines are the right way to do it. It doesn't say that a MacBook can run a person or an H100 can it. It's a much more general position. It's not an empirical hypothesis. It's a metaphysical position. Computationalism is a theory of representation, and functionalism is a theory of epistemology. So it's not empirical, it goes before empirical ideas. So what is epistemology? Epistemology is the field in psychology that is concerned about what is the nature of knowledge, what is the nature of truth, how can you claim something to be true, and why do you do this, under which conditions. And in computationalist functionalism, what's foundational in epistemology is information. Information is basically discernible differences. And the meaning of information is the relationship that it has to changes in other information. This is models that we are building that relate information to each other. And the invariances in these changes to information, this is what we call functions. They're basically mappings from certain patterns to other patterns that allow us to model transitions in the world, the dynamics of it. And the objects that we observe in the world, we construct them over the invariances in those relationships. And this is what we call functionalism, right? So objects are bundles of functions. And the objects are basically sub-universes, because we cannot comprehend the universe as a whole. We carve it up into little small systems, and these systems are tightly coupled within and loosely coupled across each other. So if I have an object like this, I can take this from the ground, and the ground doesn't change very much. This object doesn't change very much, because the relationships between this and this are relatively sparse, and the relationships within this are such that if I break them, the object disappears for me in the way in which I model reality. Right? But causality would be the interaction between, for instance, this thing and the table, and the table stops it from falling down. Right? And it's a causal interaction where these two subsystems of the universe that I am using to model reality are interacting. And so causality in this perspective is an artifact of us separating in the universe into subsystems, which is not naturally the case. So we impose the separation. As a result, we get interacting systems. This interaction is causality. And knowledge is a representation of a model in some kind of language that is describing the predictive and observational patterns.